All right, welcome to day one of circles where you are self-pacing yourself. So please note this is all due next week, Friday. That's when you're going to take the quiz. And this is your study guide. So the quiz questions will be taken directly from this packet. So we're going to start our unit on circles. A couple of vocabulary words that are important. As you can see here, we have a circle. And if you have a line like this that intersect your circle at exactly one point, so this would be point B, then we call that tangent. Okay, so it's tangent to the circle. The cool thing about the point where a circle, this is what we call the point of tangency, and a tangent line is a line that hits a circle in exactly one point on the outside of the circle. Okay? And this point right here is what we call the point of tangency. What's cool about a tangent line is that if you were to draw a radius, so again, this line right here is your radius. So a radius cuts a circle in half. It actually makes a 90-degree angle with the radius of the circle. This is how we indicate, that's what we call the center of the circle. Okay? And this point P is what we call the point of tangency. This right here is what we call point P. And you can see here that it makes a 90-degree angle. So that's going to be important for the information that we are going to learn. Excuse me. So the first thing we're going to identify whether or not we have a tangent line. Okay, so we think that this line right here, so this is the point of tangency, so this line right here is our tangent line, and we want to decide whether or not that's true. All right, so we know the lengths of all three sides, okay? And we want to determine whether this angle right here is a 90-degree angle. And so to do that, we use the reverse of the Pythagorean theorem. We know that a squared plus b squared is going to equal c squared, okay? So I'm going to label this a, this b. That does not matter, but this has to be, I'm sorry, let me redo that. Woohoo! I'm going to label this C, this A, and this B. The C has to be across from the 90-degree angle, and it's also the longest side. And now I'm just going to plug those numbers into my formula, which I do here, and I see if it comes out true. And what I notice is 7 squared plus 24 is 625. And 25 squared is also 625, so it comes out true. Therefore, I can predict, or I can conclude that this is a right angle and a 90-degree triangle. All right, so let's go ahead and use this diagram again and see if we understand. So I'm going to redraw that circle, and I'm going to pick my center point here. And I'm going to call this point M, this is point N, and my tangent is going to, the point of tangency is right here at L. So my tangent line is going to hit here, and here's my radius. Now I want to test, it says NL is 4, so from N to L this is 4, and then it says ML is 7, from M to L is 7, and N to M is 8. So I know all three of my sides, and I want to test if this right here is a 90-degree angle. Again, the 90-degree angle is made with the line tangent and the radius. So I know that this is side A, B, and C. So I'm going to do 4 squared plus 7 squared equals 8 squared. Well, 4 squared plus 7 squared is 65, and 8 squared is 64. So these do not equal each other, therefore, no. LM is not tangent. All right, practice this by doing numbers 1 through 4 in your packet. Pause the video, work those out. I did number 1 for you, and I'll have the answers on the canvas for you to check. Okay, these are the notes for numbers 5 through 12, assuming you have done 1 through 4. You've completed 1 through 4. Okay? We're going to use the same theory to find missing angle measures. All right? So once again, we got to remind ourselves that we're going to assume that, well, we're not going to assume this. We're told that ML and MN are tangent to point O. So what I can say about this is because this is a tangent line, I know this is a 90-degree angle. And because this is a tangent line, I know this is a 90-degree angle. And I want to find the value of X, which is the measure of angle M. Well, this is a quadrilateral, and I know that all angles in a quadrilateral, because there are 4 sides, add up to 360 degrees. So I literally just do blank plus blank, part plus part plus part plus part, equals the whole of 360. So I fill in 90, 90, 117, and X. 90 plus 90 is 180. Plus 117 is 297. So when I subtract out, I get X equal to 63. So the correct answer here. Okay, and it's worked out again another way downstairs. All right, so let's look at this situation here. In this situation, we're not looking at quadrilateral. We're looking at a triangle. So this time we know that our angle measures are going to add up to 180. Blank, and there's only 3 angles here. One of them is 38. This one I know is a 90 because it told me it's tangent. And so I've got a 90 plus X. So 38 plus 90, I'm going to go ahead and type this in my calculator. When I type it in, I get 52. So that means that X equals 52 degrees. All right. Those are a couple example problems. You should be able to do numbers 5 through 12 at this time. Please note I did quite a few model problems for you. The key is to know whether you're going to do 4 angles or 3 angles. Is it going to add up to 180 or 360? Here's a word problem for you. We've got this CN Tower in Toronto, Canada. It has an observation deck 447 meters above ground. About how far is it from the Earth's horizon? So please remember this would be the Earth's horizon here. All right, so we want to know how far is that from the Earth's horizon. So we're looking, if I drew a tangent line here, let's say, right? And we know that the Earth's radius is 6,400 kilometers. Okay, so I know that, first of all, I'm going to have to move the decimal place over twice. So this is about 4.5 kilometers. Okay, and then I got the Earth's radius, which is going to come down. I can't draw it on here, but it comes down this way. And it also is going to come down this way, right? So that's kind of what they're showing here. This is the Earth's radius here, okay? And that's 6,400 kilometers. So this is also 6,400 kilometers. And the horizon line is going to be a tangent line from the side of the circle. So here's where my 90-degree angle is here. So this side, this whole side here is my hypotenuse. This is my side A, and this is my side B, which I do not know. So this time, I'm going to use C squared minus A squared, and that's going to give me B squared, which is this distance right here. That's what I'm looking for. And you can see they've typed it in for you down here. I'll just put the numbers in for you. So this is going to be 6,400.45 squared minus 6,400. And that's going to equal squared, b squared. So the very last thing you're going to have to do is take the square root. You can see they filled in the numbers for you at the bottom. All right, let's do another example problem. In this situation, you want to know a person is, so here's the Earth, and we got this person in an airplane. All right, so here's the airplane. You all know you love my airplanes. Airplane above Earth, right? So here's the horizon line. And there's that person sitting in the airplane. Oops, I need my center. Right here. And I want to know, this is 2 miles. This perspective is terrible. The Earth is really small compared to the airplane, sorry. I want to know this side again. How far the person can see back to the horizon, back to the Earth's horizon. And this time I'm looking at 4,000 miles. So this is a radius, this is a radius. So both of these are 4,000. Okay, so this is my entire hypotenuse. So this is going to be 4,002 squared minus 4,000 squared, and that's going to give me b squared. And when I work all this lovely mess out, you end up with b equaling 127 miles. At this time, you should be able to do numbers 13 through 20. And the last thing we're going to learn about tangent lines is if you have a endpoint outside a circle, the 2 tangent lines are congruent to each other. And so we mark this up by showing 2 tick marks like this. Don't forget, they're also going to make 90-degree angles with the radius, but those sides are also congruent to each other. So we're going to use this information. This is really fun. If you have a circle, we call this inscribed. It's a circle inscribed by a polygon. And you remember a polygon is a shape that has more than 3 sides. 3 sides or more, right? So we're going to fill in information. So if this is our outside point, and we know this side is 10, then I know this side is also 10. This is my outside point C, and this part right here is 8 centimeters. Well, then I know this side is also 8 centimeters. And the last go about of the circle is I know that this part right here is 15. So this part right here is also 15 because they share a common outside circle point of B. So if I wanted to find the perimeter of this polygon ABC, knowing my inscribed circle here, I can just fill in the missing information and add it all up. So 10 plus 10 plus 8 plus 8 plus 15 plus 15 is 66. So this would have a perimeter of 66. Okay. Let's try another one. Here's our picture, so let's first fill in what we know. This is our common endpoint outside of a circle with a tangent here. So if this side's 15, this side's 15. Here we've got our point outside of a circle, so if that's 17, that's 17. Now the interesting thing is we don't know this last part. This is what we're trying to find. But we know, we'll just call it x, and we know they're equal to each other, and they're both x. And so we also know that the perimeter is 88. So we're just going to work backwards. We're going to say that 15 plus 15 plus 17 plus 17 plus x is going to give me 88. And this just simplifies to a simple two-step equation. This is 2x plus 64. So you just subtract 64. 2x equals 24. Divide by 2. X equals 12.